Hi folks, this is Dr. Surasingha with the Soundscape Ecology class, and today I'm going to go over the data analysis process. Um, and I'm actually using exactly the same data that you guys generated, or rather what we have plus what we collectively generated. And I know as I speak, you guys are probably in the process of processing the data using KPro, Kaleidoscope Pro software. Um, and what we have done is, Professor Amur has run all the data through KPro and generated this output. So first, let's take a look at the output and try to understand what it is telling you, right? And then I will go over how to do the analysis and I will share the output with you. So first up, so this is actually there are two data tables you see over here. On the top, this top part is actually the data that corresponds to or data collected after the BSU was shifted to a full online format, right? It starts from as early as June and goes until up until September. So this includes data that you guys collected. Okay. The bottom table, it's actually the data from the year before, that is before BSU campus was shut down, or when everything was actually taught in person. All right. So but remember, even in June, July, you might ask the question, wait, that's summer. Yeah, but it's still the campus was operational, right? There are people are fully engaged in activities, right? And we have actually comparable data set between year 2020 and year 2019. um, so corresponding to before shutdown and after shutdown, right? So now let's take a look at each data column. First data column goes by time, that corresponds to the different months and years that data collection was performed. And all the data collection that you are looking at over here comes from BSU campus, right? In the Woodland area, kind of in and around the tower a lot, right? That's actually a huge acreage of woodlands. And there's a lot of bat activity that we have been recording from that environment. So it's a good, and the other advantage is, not the advantage, other reason is, those are actually hiking trails. So when the campus was shut down, you can actually kind of ask questions yourself or develop other hypotheses. How much those hiking trails were used by the local people? They were open to public. So although the campus was shut down, would you expect those hiking trails to be frequented by visitors? Because there's nowhere else to go. And as you know, most of the natural areas were shut down during the pandemic response, or as a pandemic response. But our woodlands were not shut down, so it was open to public. So keep that in your mind when you interpret these results. So, and the other column is actually kind of a session ID. The second column, column B, is the session ID, right? That one. And then these columns, right, from CD through J are actually different species, right, that we found over there, right? And we will actually upload a when I upload this to Blackboard, I will actually mention what those species columns mean, because these are acronyms. And then what I have done is actually, what is these two columns, K and L? K is species richness, meaning in this particular session, so each row in this column corresponds to a particular night session, right? And you can roughly see there are about 3 to 4 weeks, or 3 to 5 weeks of data collection happening in each month, right? So each row indicates over here in column K how many species were recorded per each deployment session, not per night, per deployment session, right? So a single deployment session corresponds to multiple nights corresponding roughly corresponding to a particular week, as you can see. And then the total number of total calls is kind of a proxy of total abundance or total activities recorded per each deployment session, right? Again, corresponding approximately to a week or so. And so total calls, again, what species richness, what I have coded over here in this particular script is actually I counted each column that actually has a recording over 0, right? And that's how Vitality spaces richness, right? So here there's 3, and below that 4 spaces, 5 spaces recorded, 6 spaces recorded, so far and so on. And then total calls is actually summation of all of these activities, right? So K is actually spaces richness. L is actually total number of incidences where all species were collectively recorded, right? And again, just explaining what's happening over here, right? In these columns from C through J, those numbers indicates how many different calls were documented per each deployment record for a particular species, right? And so here actually I kind of included now what those column names means. They correspond to each species. I included the common name, and you can actually look up the scientific name as well. I just didn't have enough time to include the scientific name as well. It's good to know the scientific name in general. And so I did explain the construct of the column, right? And then let's go into doing some preliminary data analysis. First, let's compare the species richness and total call records between and after, right? Species richness tells you how, whether the species richness was significantly different before and after shutdown. And the second one, total calls, tells you the activity patterns, right, before and after shutdown. So that tells you whether the activity patterns are significantly different before and after the shutdown, right? So those are, I'm going to do those 2 examples, right, just for fun. And okay, now remember how you do that analysis, right? To do this, you need to have Excel. Like the online versions will not help. And you will need to use this actual downloaded, this actual desktop version of Microsoft Excel, and it is freely available to all the students at BSU. And it should be able to, you can work this through from both Mac systems and Windows operating systems. Windows operating systems are relatively easier, and I'm using a Windows operating system because I don't have access to Mac operating system on campus or personally. So if you take a look at this particular document, right, this actually takes you over, give you the details of the manuscript writing process, right? And it actually gives you a couple of links, like over here, right, to that describing you how to set up your Excel with the statistical analysis tool, which should appear by default, but if it does not, there are very easy ways to tweak it and make it appear. So the second reference actually tell you how to include that particular data analysis tool into Excel, right? And the first reference takes you through how to do it, particularly with respect to the t-test, which is relatively easy to do, and most of you have a basic background on statistics, and it's easy to understand what a t-test does, and I will explain that briefly in a moment. Before I go over and explain you the statistics, I wanted to highlight the importance of picking up a hypothesis, right? Now I have provided an example hypothesis, and I'm going to test that one. I have no problem with you using the same hypothesis that I'm testing, right? And I'm going to add another hypothesis, not just species richness. I'm going to go with total activities before and after shutdown, and compare that as well. But what I'm trying to say over here is it's completely okay to use the hypothesis I'm using, right? But if you want to take an extra step, right, and explore this analysis furthermore, you're more than welcome to do additional analysis. For example, if you look at my data, there are multiple species recorded, right? And some of those species are actually rare, all right? For example, little brown bat is state endangered, right? And then northern long-eared bat is federally threatened. And Indiana bat, I don't know whether we have any records of the Indiana bat, but several species that we actually have documented on campus actually are rare. or endangered at state level and one of them at federal level. So you can actually pick one of those examples. You can pick a single species or multiple species and develop a hypothesis on that one as well. And how many hypotheses do I want you to develop? Just one. One is enough, right? So, and it is completely up to you whether to use exactly the hypothesis I'm using or come up with your own. When it comes to grading, I don't care which one you're using, right? It's completely completely up to you to pick your own or follow mine. But what you would need to do, even if you pick my own hypothesis, is to go around and read literature to rationalize the hypothesis, right? To develop your introduction part and the discussion part, you will need to read. So even if you picked mine, you will have to do some reading about it. Don't shy away from picking up mine. I have no problem with you doing so. Okay, let's get back to the data now. So, now I want to compare species richness before and after shutdown. So I'm comparing two different groups of data, right? The same variable, species richness, after two different groups come, because each group kind of corresponds to a different treatment, and the treatment in this case is shutting down the school, right, or moving everything from in-person to online. So when you're comparing two groups, right, and particularly when you have unequal sampling efforts, like over here you have 18 rows, meaning 18 deployment sessions, and before shutdown we have a fewer number of deployment sessions, but they are not that different from each other, but you can see the sampling efforts are roughly unequal. So there are many statistical tests you can use to compare species richness before and after shutdown, and I'm using one of the most simple tests called t-tests. There's another alternative called the z-test. There's nothing wrong with that, but since the sampling numbers are not equal, I'm little hesitant to go towards z-test, and z-test requires a larger number of samples, 30 or greater, and I don't have that many, so that's another reason why I am going for the t-test instead of the z-test. And also z-test requires that your data to be perfectly normally distributed. T-test is relatively robust for violation of the normal distribution. And even if you compare the actual z-test versus t-test statistical distribution, z-test is a perfectly normal curve. T-test is actually tends to have shorter tails in the statistical distribution. So that's a very basic 101 to the statistics, and I'm trying to not to go too much into statistics. I tend to do that because I love talking about stats. Okay, so in your Excel sheet, go to data, right? Click data, and when you enable this statistical tool, you can click data analysis, right? That actually, if it is not showing up, go to one of those tutorials and it will show you how to enable data analysis option under data. So before you do a t-test, right? I mean, if you want to do a t-test, right, when you actually scroll down to the options, there are several options. One is t-test paired, right? Paired samples for means. Now, this is not actually paired. You might think it's before and after, but remember that we don't have the exactly same subject or exactly the same experimental unit being exposed to before and after, right? It's not actually like, I'm picking a the same set of animals and and then recording their responses to before and after. No, so my sample comes from my samples are two different coming from my data is coming from two different samples. It's not the same experimental unit exposed to before and after. And then so it's not the paired option, right? For example, if I were to measure your weight before exercises and after exercises, then I have to use paired t-test, right? And then there are two more options. Two samples t-test assuming equal variance, assuming unequal variance. So as of now, we don't know whether the sample variances are equal or unequal. So first, in order, we have to know which test to pick, unequal variance or equal variance. So we have to do a preliminary assumption test so that we know what direction to go to, right? So that test that we are going to do to test for variance is called the F-test, right? It's right over here. And what you do is, and again, directions on how to do this are available with the first link in the handout. So I'm going to click OK over here, and then this particular window opens up, right? So, and then in the F-test, let me explain the F-tests very briefly to you. F-test teaches you, or it helps you to determine if the samples you are comparing or the groups you are comparing have equal variance or unequal variance. So in the F-test, your null hypothesis is that your two variable sets, your two samples have equal variance, right? And the alternative hypothesis is that your two samples have unequal variance. So remember the null hypothesis, right? It is actually equal variance, meaning no significant difference between variance. Now, variable 1 is actually my species richness, and I will keep in my head that I'm going with after versus before. There's no reason for that, particularly as of now. It's simply because my after comes up. Now, and then go to variable 2, right? Move your cursor to variable 2, and then select that particular data range, right, from the data column, right? And then and if you look at this particular window, you can say it says alpha, right, should be equal to 0.05, right? And then that's fine, because alpha means what? It's actually 100 minus the confidence interval, right? Remember from your ecology, in biological sciences, largely in ecology, the confident interval we use is 95%, right, which corresponds to what? 2 standard deviations around the mean, right? That's actually the confident margin that you are interested in, and whatever the left, the 100 minus 95, is actually your alpha. So in this case it's 0.05, and we will keep 0.05. You can change it. You can go for a lower alpha, meaning you can increase your confidence interval. So if you apply much lower alpha, like 0.025, right, that's also possible, but I don't have any reason for that, right, over here. And or you can actually increase your alpha, like let's say, like, I don't know, 0.1. Again, there's no reason for doing that. So let's keep this as it is, and then the last thing we need to do is tell this window where to include the output range, right? And output range, I want it to be somewhere over here, right? So select output range, right, and click this cursor over here, and like I want that somewhere over here. Let's say over here, right? And okay, right. So, and this is actually for species richness before, after versus before, right? And so let me show you something that actually I intentionally did when I ran the test. I don't need these 3-4 default meaningless names, right? I mean, it corresponds to the first and second variable, right? First variable will be species richness after, second variable is the species richness before, right? So what I'm going to do is I'm going to kind of get rid of this, right, and redo the analysis. So data analysis, F-test, okay. My data range is the same, that versus this, right, and then that versus this, right, and uncheck labels, right, and hit OK, right? There you go, right? I will just copy and paste it over there. Yep. So now, couple of things I want to highlight. This is a strange way how Excel based software works, okay? So make sure that the mean values for variable 1, right? Sorry, the variance, not the mean value, the variance for variable 1 must be greater than variable 2. Okay, again, be sure that the variance of the variable 1 is greater than the variance of the variable 2. In my case, it is, right? If not, what you need to do is you need to flip what you select for variable 1 versus variable 2 over here, right? If that is the case, what you need to do is over here, flip these two values, right? Why? Simply because the statistical software works in a very strange way. It has to be, inserted in that way. Otherwise, it wouldn't work properly. Now, and then I'm going to take a look at compare my calculated F statistics with the tabulated critical F statistic. And remember, we are doing a one-tail test because we are looking at whether the variance is equal or not, right? We are not saying variance is greater than. So since it's actually variance is equal or not, in this case, we are following the one-tailed test. And if you wonder where this F value, calculated F, came from, it is the ratio between variable 1 variance divided by variable 2 variance. Okay, I mean, you can do the math yourself and like you will reach this value. Now compare this calculated F with critical F. My critical F is slightly greater than the calculated F. So if calculated F is greater than the critical F in my one-tailed test, we reject the null hypothesis, right? If my calculated F is greater than the critical F in the one-tailed test, we reject the null hypothesis. But in my case, it is not. My critical F is greater than the calculated F. So I fail to reject null hypothesis. Now, remember, what was our null hypothesis? Variable 1 and variable 2 variances are not significantly different, right? So, meaning my variances between before and after samples are not significantly different. So now I know what t-test to use. It is, I'm going to use equal variance t-test. Well, it's as simple as that. Now let's go and do that. Before doing the t-test, I want you to first think about the null hypothesis, right? So the null hypothesis for the t-test is that the two data sets, the two samples we have, right, before and after means are not significantly different, right? That is my null hypothesis, right? Null always says no difference, right? My alternative hypothesis, or I would rather say biological hypothesis, is that the species richness before and after shutdown is significantly different, right? And null hypothesis says that before and after shutdown, my species richness samples are not significantly different. So how do I do that? I go back over here, data analysis. Now I know it is a t-test, and I know a t-test what I'm going to use. I'm looking for equal variance t-test. Thanks to my f-test, I know that my data have equal variance. Okay, it actually creates, opens up a very similar dialog box. So for the variable 1, I am picking before, right? And for variable 2, for variable 1, I am picking after. For variable 2, I am picking before, right? And my hypothesized mean difference should be 0, right? Because my null hypothesis says that before and after means are not significantly different, so that's what it should be, 0, right? And then I want my output on here, right below, let me say, right below this one, right? Okay, now look at your the output over here, right? So now you are going to go by actually the two-tailed option, not the one-tailed option. Is your calculated t statistics greater than the critical t statistics for is your calculated t statistics greater than critical t statistics for two-tailed tests? Well, no, right? My critical t for two-tailed tests is greater than the calculated t, and in this case I failed to reject the null hypothesis. And now remember, what did the null hypothesis say? Null hypothesis stated that my before and after species richness values are not significantly different. So I have to accept that my null, because I do not have sufficient evidence to state that those two species richnesses before and after were different. And also, if you look at the p-value for the two-tailed t-test, you can see that value is greater than 0.05, right? So that's a very high probability value. That probability value indicates that the differences you observe between before and after species richness can be derived by random, right? By random luck, right? So the probability of those two species richnesses being different is nearly 50%, right? So that's very high. That random probability of species richnesses being different is way too high. So as such, we have no evidence to suggest that the lockdown or the online movement of the lockdown, campus lockdown, has no significant effect on changing species richnesses of bats before and after shutdown. So that's the conclusion based on my data, right? Again, no significant differences in species richness. Let's actually do the same for total calls. How about that, right? Let's save this, and actually I would rather create a naive data column for that over here, right? And I'm going to do the same, make sure that I can get to see all the data, right? So I'm going to data analysis. Remember what I did? I first want to do the F tests, equal variance or unequal variance. Now for that, delete whatever the previous values you have, right? Variable and variable 1 and variable 2. First, you select that range, done. Select the other range for variable 2, and let's see what comes up. Okie dokie. Let me see. First, remember the very first thing you have to be concerned with, right? Is variable 1 greater than variable 2? In my case, yes, it is. Right, let me move it a little further up over here, and then let's look at the F critical and F one-tailed, right? So my F calculated is again less than F critical. So remember what my null hypothesis is, that the two variances are equal. Those two variances are not significantly different. So seems like I cannot reject my null hypothesis, right? Because my critical F is greater than calculated F, right? So I'm going to go by equal variance t-test. So again, I'm going up over here, data analysis, data analysis. Now I want to go for t equal variance. Voila. Yeah, my species richness is already selected for me because of the previous action I did. Well, I have to delete it, right? I have to delete it. It's not species richness. Now I'm looking into total calls, right? And so variable 2, I'm looking into again total calls, right? And the output range, it will actually pick something random for me. I'm fine with that. And the hypothesized mean difference, it is 0. Alrighty, what are we looking at here? Well, let's take a look at my calculated t and compare that to my critical t for two-tailed. Again, my critical t for two-tailed is greater than my calculated t. I failed to reject my null hypothesis. And again, if I look at my two-tailed p-value, it's greater than 0.05. So I failed to reject my null hypothesis. So this also indicates that there was no significant difference in bat activities before and after shutdown. Seems like for BSU campus, the lockdown has no significant effect on number of bat species that were active, nor did this that impacted the bat activities. Seems like they were fine on their own. So you could think about different reasons to explain that. Well, because campus were maybe campus students do not actually remain active in the woodlots very much. Maybe that's one reason, right? Or maybe the bats on campus populations are very resilient, and they are able to tolerate the disturbances operating, right? And besides, those bats are mostly nocturnally active, and you may not have much activities going on in that particular woodlots. Um, there will be less interference between human disturbances and their activities during the night time, right? Kind of gets back to what I mentioned regarding, how the anthropogenic activities interfere with animal activities, right? And I did mention that certain animals tend to remain active outside the human disturbances. So this could be an evidence of that. Or maybe, although the students are no longer on campus, right, the locals visiting the woodlands are actually kind of compensating for the lack of disturbances. So you can come up with many explanations to provide to counter argue this, right? Well, this is actually basically end of my 2 explanations. I'm going to upload this particular data sheet to Blackboard, and again, you are more than welcome to use my own analysis. You are welcome to go on and do your own analysis. It's completely up to you. And also remember that if you are going to go by species-specific analysis, pick one species, maybe one of those endangered ones, and their names are over there. Well, with that, I conclude my lecture on statistical analysis. If you have any questions, I'm still going to keep that office hour open for the next week. Well, have fun writing.